Okay, so now we are moving on to the wave function. Right, so we've been looking at different stuff to do with sine and cos. We've been looking at proving things. We've been looking at our double angle formula and our compound angles. So all of this time, the thing we can't forget is that these are waves. So we know that's roughly what a sine wave looks like. Yeah? And we know that roughly a cos wave looks like this. Okay? And we have waves are what is produced by, like, sound comes in a wave. I know if you don't do physics, I apologise, but here you go. So sound is a wave. Okay? But if you think about it, if you've got like a choir or an orchestra or something, you've got lots of different people making lots of different waves. So this is like a choir. You've got one person making that noise, all the sopranos make one, and then all of the altos make a different noise, and then all of the other ones make a different one again. But what you hear isn't that mess of waves that I've just drawn. You kind of hear just one sound. It all combines together, or it all adds together, and you just get one nice different wave than what you started with. So what I'm saying is you can start with any kind of cos wave, add it with a sine wave, and you get another wave which is of the same kind of form, and that's where we're going. So what we're actually looking at is functions in the form. Okay, so we look at it as f of x, so a function of x, which is equal to a cos x plus b sine x. So we've got some size of cos wave and we're adding it to some size of sine wave. Okay? And we can take that, and like I said, you've got those two waves, but you don't hear kind of two different things. You hear it all as one sound, like it combines together into one. And so we can combine those, and it either goes in the form of k cos of x plus alpha, or k sine of x plus or minus alpha. Okay, so that's the kind of exposition of where this is all coming from, what this is about, and we'll go on and we'll do some examples on how we're actually going to use this in practice. Okay, so we get told, that we have a cos x plus b sine x, and then we have to take that, and what we're going to end up doing is either putting it into k cos of x plus or minus alpha, or we're going to put it into k sine of x plus or minus alpha. Okay, so it's going to go into one of those. So we need to find, in our first one, we have two variables. So we've got our a and our b. And we're going to have to get, in our next one, we've got two variables again. So we've got k and we've got alpha. So we've got two unknowns and we've got two unknowns. So we'll get there eventually. Okay, so when we get there, we kind of find simultaneous equations where we like multiply stuff out, and we're going to end up with, k cos alpha equals a, and k sine alpha equals b. Okay, where this comes from is from multiplying out our equations. We'll come to that later, but for now, just accept those as we are, okay? So, we know we've got to find k and we've got to find alpha. So this is simultaneous equations, but it's not quite how you've seen them before. It's going to have to be a little bit different. So in here, we're going to have to use things we know already, because to find the alpha, which is what we're going to do first. So first we're going to find the alpha. So we've got these two equations, and what we need to do is we need to divide one by the other. And we use the identity that we know that tan of anything, tan A, is equal to sine of A over cos of A. Okay, so we know that, so we're going to use this here. So if we want to find tan of alpha, we know that we're going to take what we've got here, so we put our sign on the top, so we've got k sine alpha over k cos alpha. Because we've got a k on the top and the bottom, they cancel out, so that gives us our sine over cos, which is what we need. And then we also know that k sine alpha is b, and k cos alpha is a for this one. So therefore we know that tan of alpha is equal to b over a. So we can then get alpha, which is the inverse tan of b over a. Okay, and here, depending on if you've got degrees or radians in your question, will depend on whether or not your answer is going to be in degrees or radians. Okay, right, so we found our alpha, and it's going to be in degrees or radians, doesn't matter. And the other thing we've got to find is our k. So, using another thing that we know that sine squared a plus cos squared a equals 1. Right, so we're not going to be using this right from the start, but we're going to have to use that in there. So for our simplest equations, normally we're just adding them together or subtracting them. That's what we've been doing so far. But we're going to do a little bit different here. We're going to square them and then add them together, because we've got, in here we've got a squared, yeah, but we've not got a squared here. So we've got to be able to use this identity to help us. We need to create a sine squared and a cos squared, so we're going to have to square what we've got here. So if we square it, we've got k sine alpha squared plus k cos alpha squared equals k sine alpha is b, so we get b squared plus a squared. Okay, when we multiply, like square out our brackets, we're going to get k squared sine squared alpha plus k squared cos squared alpha is equal to, and then this I'm just going to rearrange to a squared plus b squared because we like it in alphabetical order. Okay, so then we can take out a factor of k squared on this side. So k squared times by something gives us k squared sine squared alpha. That something has got to be sine squared alpha. And then we've got to have, in here, we've got k squared times by something gives us k squared cos squared alpha, and that something has got to be cos squared alpha equals a squared plus b squared. Okay, so then this is where this identity that we've got up here helps us out. That can go in here, just becomes 1. So then we get that k squared is equal to a squared plus b squared. So therefore k is equal to the square root of a squared plus b squared. Okay, so that's kind of where everything comes from and what we've got to know. So we've got to know this bit here and this bit here. That's just letting you know where it comes from. So we're going to do an example first, just from knowing those. Right, so if we get told that k cos alpha equals 3 and that k sine alpha equals 4. Okay, so using our formulas that we had before, we know that k is equal to the square root of a squared plus b squared. And our a and our b are just these here. So we know that k is equal to the square root of 3 squared plus 4 squared. So that's the square root of 9 plus 16, which is equal to the square root of 25, which is equal to 5. And all those steps, if you're okay kind of skipping them all out, you're more than welcome to. Okay, not a problem. So then we have our tan of alpha. It's going to be equal to, it's always the sine over the cos. So it's k sine alpha divided by k cos alpha. Because we remember that sine divided by cos gives us tan. So therefore the sine gives us 4, the cos gives us 3. So alpha is going to be equal to the inverse tan of 4 over 3. And that is 53.1 degrees when we round it. Okay, so I'll just give you quickly one more, and that's going to be if we've got that k cos alpha is equal to minus 2 and k sine alpha is equal to 5. Okay, so start off, it's the same. K is equal to the square root of a squared plus b squared. So we get the square root, and this time we've got to be careful, put the minus 2 in a bracket, and then we get plus 5 squared. Okay, so we're going to get the square root of 4 plus 25. So we get the square root of 29. There's nothing really nice we can do with that, so we just leave it as a third, not a problem. So then we get the tan of alpha is equal to k sine alpha over k cos alpha. So k sine alpha is 5, k cos alpha is minus 2. So here we get minus 5 over 2. And this is where we need to start thinking about kind of what quadrant this is going to be in. So we've got to do our cast diagram, or Amanda says trig cool. So our sine is positive, so it's going to be these two, yeah? And our cos is negative. So that's got to be these two here. So we know our answer is going to have to be in that second quadrant where we've got those two ticks. Okay, so we find the relative acute angle, same as we did with trigonometry in National 5. So that's the tan to the negative 1 of 5 over 2. We ignore the negative for now. And we get that it is 68.19859. Okay, so that gives us what it would be in our first quadrant, so kind of in here. So we know that we've got to subtract that from 180. So our alpha is going to be equal to 180 degrees. Take away that 68.19859. So we got 180, take away the answer, and it gives us 111.80 degrees if we round to 2 decimal places. Okay, so that's the start of our wave function, and you can get on with the first exercise on that from now.